At the University of Warwick in the West Midlands of England, researchers are driving new technology for building designer polymers. So what exactly are polymers and why are they important?
Pretty much everybody has got the word polymer or plastic in their vocabulary, and we learn this from a very early age. Even 2 or 3 year olds, when they first learn to speak, will be saying, "Give me the plastic toy," and plastic is a type of polymer. And as soon as we mention the word plastic, people usually have some type of picture in their head, and usually that might be a plastic bag, or it might be some garden furniture, or it might be a pen made of plastic. And polymers have been used to replace traditional materials in these type of applications for many years.
Polymers are complex molecules that nature itself uses to build things. DNA, the building blocks of life, is a polymer made from just 4 different monomers joined together in varying ways to produce all the different types of DNA, leading to the almost infinite variation in human characteristics. In everyday life, we use chemically created polymers for a series of diverse applications. Increasingly, we require polymers to meet the demands of new technology rather than replacing natural materials. For example, in modern hairsprays, the objectives are to stick hair together in order to resist humid environments, while trying to keep it feeling natural, as well as having a product that is soluble in water, otherwise it won't wash off. Quite a complex set of requirements for a relatively inexpensive material.
More and more consumers and people in everyday life have more higher demands on the performance of the materials that they use, and they could be in drug delivery, so they want drugs to last longer or drugs to perform better, through to adhesives, that they want adhesives to stick better, and they stick more and more diverse things together, through to things that we probably don't associate with polymers. So if you have a mobile phone, you want the battery to last longer, you want the display to be bigger and more colourful and to display more information. Now all of those things are due to new modern polymers.
At Warwick, the polymer research team are looking at the need to build new synthetic polymers to meet the needs of advanced applications. They have developed a technique that allows them to build synthetic polymers 1 monomer at a time, in an attempt to approach the degree of sophistication exhibited by natural polymers. By using an approach called living polymerization, Professor Haddleton and his team are able to grow complex polymer chains outside of the harsh laboratory conditions usually associated with work of this kind, which has limited the commercial application of this chemistry.
So if we think of a simple polymer, many simple polymers just will be repeat units of the same structure. So if we think of a green bead as being styrene, this molecule would be polystyrene. If we want polyethylene and a blue ball is ethylene, then when we put lots of ethylenes together, we would have polyethylene, and we'd have molecules with different properties. If we wanted, however, to mix them and increase the amount of polymers that were available to us, we would traditionally mix them in a statistical or random fashion. But say, for example, we wanted to have a molecule that actually had the properties of both ethylene and styrene. How would we do that? And say if we wanted to have a special end group on our polymer chain that again was chemically linked to the polymer chain but may have a very special property, such as binding to an antibody, which we may use in attacking a particular tumour. Well, our process allows us to start a chain growing with a particular functional group, in this case red. And then we will just add blue groups, which would then all add at the same rate. We may then add green monomers to form this block copolymer. So now we have a polymer which would have the properties of blue and the properties of green.
The university has now created Warwick Effect Polymers, a spin-off company designed to take the work done within the research laboratories up to the larger scale quantities required for consumer testing. With considerable potential in the pharmaceutical and healthcare industries, as well as long-term benefits for the environment, Warwick's new generation of designer polymers is an excellent example of some of the valuable and practical solutions coming out of today's university research programs.